In this lesson, we solve a production planning problem with activation. A facility has 5 products and 10 production cells. Each product has a demand and a production rate, and each cell can produce only certain products. Our goal is to satisfy demand using as few active cells as possible. We have 5 products. Each has demand and production rate, 10 cells, each can produce some subset of products, open as few cells as possible while meeting all demand. We want to open the minimum numbers of cells that can cover all product demands. First of all, we need to write a table with all the data. Each product has its demand and his rate. For example, product 1 has demand 12 units and can be produced at rate 10 units per hour. Not every cell can make every product. This capability matrix shows which products each cell can produce. For example, cell 1 can produce P1, P2, P3, but not P5. This means when we assign production, we must respect these feasibility constraints. Here we have the table, and here we have demand, we have production rate, and we have set with products, set with cells, and here we have the parameters. Here we have the capability table, and then we need to make decisions about what do we need to decide, what are our variables. The first one is yj is a binary. It equals 1 if cells j is opened. Second, xej is the amount of product E produced in cell j. And zeta is the objective variables that belongs to the total number of open cells that needs to be opened. Here we have the binary variables and positive variables. About equations, we have the different equations, and the first one is the objective. Our objective is to minimize the number of active cells. That means we want to satisfy all demand, but with the smallest possible number of open cells. And as constraints, we have the first one, that is the coverage, demand coverage, and the second is the cell feasibility. As we can see right here, the first set of constraints ensures that demand is met. The sum of production of each product across all cells must equals to the demand. The second constraint instead links production to feasibility. If cell j can't make product E, then Pej equals to 0. If the cell is not active, Ipsj that equals 0, then production is also 0. Only active cells with capability can produce. And this is essentially the whole model. Write model x2 all, so we need to solve every part of the model using mixed integer programming because we have a binary, minimizing zeta, that are the number of open cells that we need to open. And in the end, we want to display the final results with a post-process number that are the number of cells activated, that essentially is the sum of all the cells that are being activated. Thank you for watching. See you in the next video.